Hi, this is Mrs. Doris. Today we have lesson 4-4, Graphing a Function Rule. Our objective is that you will be able to graph equations that represent functions. Why are we doing this? Functions can be represented in many ways and used in solving real-life problems. Problem number 1, Graphing a Function Rule. Number 1 says find the ordered pairs that are solutions to the equation y equals 5x minus 4 if x equals -2, -1, 0, 1, and 2, and graph the equation. Alright, you will notice first of all that our x equals and our list of numbers, -2, -1, 0, 1, and 2, have already been put into the x column for you in the table. Also, you will notice that the function rule, y equals 5x minus 4, and all we need is that part of it, 5x minus 4, goes right here. And then when we evaluate that expression, we get our y, and then we have a column here to put our x and y ordered pair. All right, so here we go. First of all, we're going to take our expression 5x minus 4 and substitute -2 for the x. Evaluating this, 5 times -2 is -10, minus 4 would be -14. So we have the ordered pair -2, -14. Taking the same expression, 5x minus 4, and substituting in -1, we have 5 times -1 is -5, minus 4 is -9. So we have the ordered pair -1, -9. Substituting 0 in to the same expression, 5 times 0 is 0, minus 4 is -4. So we have the ordered pair 0, -4. Substituting 1 in, we have 5 times 1 is 5, minus 4 is 1. So we have the ordered pair 1, 1. And finally, substituting in the 2, 5 times 2 is 10, minus 4 is 6, and so we have the ordered pair 2, 6. All right, as I go to graph this, I notice that I need both some negative x's and some negative y's, so I'm going to simply put my y-axis right down the middle and my x-axis kind of right in the middle of my graph. All right, so let's plot our points. We have -2, -14, and I think what I'm going to do is on the y-axis, I'm going to go by 2's. So I will have 2, 4, 6, 8, 10, 12, 14. And going down, -2, -4, -6, -8, -10, and -12. All right, on the x-axis, I'm just going to go by single units. So I'm going to number every other one, and likewise going this way. All right, so we're ready to graph. -2, -14, our first ordered pair, would be right here. -1, -9 would be right between the -8 and -10. 0, -4 would be right here. 1, 1 would be right here. and 2, 6 is right here. So let's join our points with a line. We're going to put arrows at both ends to show that this graph continues. We could choose other values for x if we chose that to do that. And so the line will continue. Let's do another problem, and this time we're going to make our own graph. You have a table there that you can use. So x will go in first. In my next column, I'm going to put my 1/2 x minus 7, then my y, and we're going to include another column for our xy ordered pair, and this is the column that we'll graph. Now, you'll notice that in this problem they did not give us values for x, so we can choose any values that we would like to use. I'm going to choose some different ones than we had before, and the main reason is I noticed that I'm taking 1/2 of x. Well, it'll be easy to take 1/2 of x if I choose even numbers. So I'm going to choose -4, -2, 0, 2, and 4. Okay? All right, so substituting in, we have 1/2 times -4 minus 7. 1/2 times -4 is -2, and -2 minus 7 is -9. So we have the ordered pair -4, -9. Substituting in -2, I have 1/2 times -2 minus 7. 1/2 times -2 is -1, and -1 minus 7 is -8. So I have the ordered pair -2, -8. Substituting in 0, I have 1/2 times 0 is 0, minus 7 is -7. So I have the ordered pair 0, -7. And you can see the pattern that we're starting here. It appears our y is going up once for every 2 x goes up. But let's continue. We have 1/2 times 2 is 1, minus 7 is -6, so I have the ordered pair 2, -6. And finally, I have 1/2 of 4, which is 2, and 2 minus 7 would be -5. So I have the ordered pair 4, -5. All right, I see that I have all negative values for my y. I'm going to put my x-axis up here and my y-axis here along the side. No, I can't do that. Hang on. Let me draw that again. All right. Okay. I need to put my y-axis here in the middle. All right, and I'm going to label it. All right, so here we go. -4, -9 would be going left 1, 2, 3, 4, and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll go right here. -2, -8 would be right here. 0, -7, 2, -6, and 4, -5. All right, and once again, we're just dealing with an equation here, so we will join all the points with a line and put our arrows at both ends to show that we could choose other values for x, and they would also be on this line. All right, let's deal with a real-world function problem. The function rule W equals 8g plus 700 represents the total weight W in pounds of a spa that contains g gallons of water. What is a reasonable graph of the function rule given that the capacity of the spa is 250 gallons. All right, and I see when I was reading that, I need a comma right there. Okay. Um, the capacity of the spa is 250 gallons. So that is as high as we can go. And so I'm going to choose that for one value of G. And then we could also not have any water in it, so I'm going to choose 0. We can't have a negative amount of water, so that doesn't make sense. And so let's see, I think I'm going to go, let's try 50 pounds, 100 pounds, I'm sorry, I'm saying pounds, 50 gallons and then 100 gallons, and let's go 200 gallons. All right, and you can choose any values for the G that you wish to use. All right, I already have my function rule, 8G plus 700 in my column. I can't remember if I put that in your notes or not, so please be sure that you label your columns if they aren't already. So we're going to take 8 times 0 plus 700. 8 times 0 is 0, plus 700 would be 700. So I have the ordered pair 0, 700. All right. Next, I'm going to substitute 50 in for my gallons. 8 times 50 is 400, plus 700 would be 1100, and that would be pounds. So I have the ordered pair 50 and 1100. All right, next I'm going to substitute in 100 for my gallons. 8 times 100 is 800, plus 700 is 1500. So I have the ordered pair 100 and 1500. All right, substituting in 200 and adding 700 to that. 8 times 200 is 1600, and plus 700 would be 2300. So I have the ordered pair 200 and 2300. And finally, my last one, 250. 8 times 250 would be 2,000, plus 700 would be 2,700. And so I have the ordered pair 250 and 2,700. Okay? All right, now we're going to do our graph. Move this out of the way. All right, and you can see that gallons, our weight is dependent upon the number of gallons. So I'm going to put my gallons, and I didn't give myself much room here on the graph down here. And my weight will be on the y-axis. Since weight is the dependent variable, gallons is the independent variable. Now, my gallons go from 0 to 250. Let's see if I can go by 50s here. That'd be 50, 100 would be right here. Let's see, there's 150, 200, and 250. Okay. And I didn't, my 150 would be right here. I'm skipping every other line. So every line represents 25. All right, on weight, I see I need to go from 700 up to 2,700. So let's go by, let's see what would work for us. Let's go by 200s. All right, so this would be 200. Next would be 400. All right, and I'm not going to number all of these. After 600 would be the next line. I'm going to skip to 800, 1,000, 1,200, 1,600, 2,000. Skipping the next one, which would be 2,200, I'll have 2,400. 2,600 is the next one, and then 2,800. All right. So basically, I'm going by 400s. Each line in between will represent 200. I'm going to move my title over here a little bit closer out of the way. Let me just rewrite that. Didn't quite get it. There we go. All right, so 2,800. And I'm going to write my title again, weight, and that would be in pounds. Okay, if we wanted to give this graph a title, we could call it weight of spa, and we might even want to include with water. All right, that will justify why we're using gallons down below. All right, now let's graph these. I'm going to choose a different color here so we can see those points. We have 0, 700, which would be right about there, 50, 1,100, 100, 1,500. All right, I can see I've made a mistake here in my graph. Here, I need to renumber. Okay, let's see, going by 400s. This is 1,600, and then 2,000, and then 2,400, and then 2,800. Okay, that's better. All right, always make sure that you double check your intervals to make sure that they are evenly spaced number-wise. Okay, so here we go. 100, 1,500, be right there, 200, and 2,300, and 250, and 2,700 would be right here. All right, and again, we're going to join these with a line. And actually at this point, because we can't have any more than 2,700, I am going to erase that arrow. We shouldn't have an arrow there. It will never be, it will overflow at that point. All right, if there's any questions, make sure that you ask me those tomorrow. Now, we have a thinking about it question, and it's partially hidden here by this. Let me see if I can move this out of the way a little bit. What is the weight of the spa when empty? See if you can answer that question. The answer is right in the table. All right, problem 2, graphing a real-world function. The function rule h equals 18 plus 1.5n represents the height h in inches of a stack of traffic cones. Make a table for the function rule. Suppose the stack of cones can be no taller than 30 inches. What is a reasonable graph of the function rule? All right, well, we're going to make our table. And our independent variable is the number of traffic cones. So I'm just going to call that number of traffic cones. Okay. And our function rule is 18 plus 1.5n. That will give us the height, h. Our number of traffic cones is represented by n. And then we'll have our ordered pair in H. All right. Well, let's see. Let's start with one traffic cone. Okay. And again, you can choose any number that you want to. Substituting in 1, we have 18 plus 1.5 times 1. 1.5 times 1 is 1 and 5 tenths, plus 18 would be 19 and 5 tenths. Okay, so we have the ordered pair 1 and 19 and 5 tenths. We can choose 2 if you'd like to do that. Let's go ahead and do that. 2 traffic cones. We have 18 plus 1.5 times 2. 1.5 times 2 is 3, plus the 18 would be 21. And so I have the ordered pair 2, 21. All right, I'm going to skip 3. Let's go with 4. 4 traffic cones. So I have 18 plus 1.5 times 4. 1.5 times 4 is 6. 6 added on to 18 is 24. And so I have the ordered pair 4, 24. All right, and I'm going to add one more number. Let's choose 8. So I have 18 plus 1.5 times 8. 1.5 times 8 is 12. 12 added on to 18 is 30. So I have the ordered pair 8, 30. Okay, so let's graph this. On the bottom would be the number of cones, which is our independent variable, N. I'll draw my axis right here, and my axis here, which would be H. Okay. Along the side, we have the height. I'm going to abbreviate since I don't have a lot of room here. And it looks like we need to go up to 30. So let's see. How about we go by 5s maybe. I'm going to skip every other line. 5, 10, 15, 20, 25, and 30. Okay? Our height is in inches, so we might want to label that. Number of cones, looks like we're going from 1 to 8. We'll just use every square as being representative of one cone. So I'm going to number every other one. All right, and let's graph. We have 1, 19 and a half, so it's going to be very close to the 20. 2, 21. 4, 24. And 8, 30. All right. You can see that these points lie in a straight line. In fact, there we could fill in other points that would also meet this condition. And for now, I'm going to go ahead and join these points. In a minute, you'll see why we might want to leave them just points alone. All right. Okay. We have two types of functions and graphs that you will see: continuous and discrete. A discrete graph is a graph that is unbroken. You will see on a continuous graph a line joining all the points with arrows on both ends. Always remember on a continuous graph to put the arrows on. A discrete graph is composed of distinct isolated points. And here you can see a set of points. Please, on your notes, make sure that you put some points on your graph. They don't have to look exactly like this. However, we are dealing with linear, so they should appear to be in a straight line. Okay? Now, problem 3, identifying continuous and discrete graphs. Graph each function rule. Is the graph continuous or discrete? Justify your answer. All right, well, our first example is the amount of water W in a wading pool in gallons depends on the amount of time T in minutes the wading pool has been filling, as related by the function rule W equals 3T. Okay, in this example, we have time as one of our variables. Time is always our independent variable. We have a function rule, W equals 3T, so I'm going to put 3T there. W is my weight, or it's the amount of water, excuse me, amount of water, and then I have the ordered pair TW. Now I'm going to go ahead and get my graph ready. I'm going to draw this will be my t-axis, and this will be my water axis. And my water is in gallons. Okay. My time is in minutes. Okay. So let's choose some values for t. Let's start off with 1. Let's go low. We can choose some other values, 2, 3, 5. Let's jump to 10. And then let's jump to, well, let's go 15. All right, that's enough. And you may not have this many lines to fill in, so you can do as you wish. Okay, 3 times 1 is 3. We have the ordered pair 1, 3. And that point would be, well, we'll wait and graph these here in a minute when we can make our scale. All right, 3 times 2 is 6. So we have the ordered pair 2, 6. Next, 3 times 3 is 9. So we have the ordered pair 3, 9. Next, we have 5 times 3, 15. So the ordered pair 5, 15. Then we have the ordered pair 3 times 10, which is 30. So we have the ordered pair 10, 30. And finally, we have 3 times 15, which is 45. And we have the ordered pair 15, 45. Now, for the sake of being consistent, I want to go back to this problem right here, and I'm going to erase that because I can see I was getting in a hurry, and I should have taken 3 times 5, although 5 times 3 is exactly the same thing. Okay? Let's graph our points. I'm going to go, I don't believe I have 15 squares on here. Let's see, 2, 4, 6, 8, 10, 12, 14. I have exactly 15. So along our bottom axis, we can go, each square will represent 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. And of course, 0 is right here. On our amount of water, I need to go up to 45. Let's make each of these squares equal to, how about going by 3s? So 3, 6, 9, 12, 15. Let's see, 18, 21, 24, 27, 30 would be right here. And 33, 36, 39, 42, 45. That's going to work out exactly right. Real nice. So every line on our vertical axis is equal to 3 units. So let's graph our points. We have 1, 3, which would be right here, 2, 6, 3, 9, 5, 15, 10, 30, and 15, 45. Now, this is one where we can have all these points in between as we're filling it with water. So this is what you would call a continuous function. All right? The water doesn't go in just 1 gallon at a time. It's continuously filling. So this is a continuous graph. In our next example, we have the cost C for baseball tickets in dollars, and this depends upon the number N of tickets bought, as related by the function rule C equals 16N. So I have N for the number of tickets. My function rule is 16N, so the tickets must be $16 a piece. That's going to give me the cost, C, and then I'm going to have the ordered pair in comma C. So preparing my graph, I have the cost is the dependent variable, and my independent variable is the number of tickets. Okay, so let's just do 1, 2, 3, 4, and 5 tickets. All right, 16 times 1 would be 16, and we have the ordered pair 1, 16. 16 times 2 is 32, and so we have the ordered pair 2, 32. 16 times 3 is 48, and we have the ordered pair 3, 48. Next, 16 times 4, 64, and we have the ordered pair 4, 64. And finally, purchasing 5 tickets, 16 times 5 would be $80. So we have the ordered pair, 5 tickets, cost $80. All right, let's put these on our graph. We can definitely go by ones on our horizontal axis, number of tickets, so I'll put those numbers right there like that. And we need to go up to 80. So let's go by tens. 10, 20, oh, that might not work, 30, 40, 50, 60, 70, and okay, we can guess where 80 will go. All right, so let's plot our points. We have one ticket is $16, right above that line. 2 are $32. 3 are $48. 4 are $64. And 6 tickets, going to be right about here. All right. Do my points look linear? And because of our scale, it can be a little bit difficult to get those. I think they do. This is one where this is not continuous because you can't buy half a ticket. So this is what you call a discrete graph, and this is one where we would not join our points with a line. Okay, problem number 4. What is the graph of the function rule y equals x cubed plus 1? All right, In our last problem, we're graphing nonlinear functions. So again, we're going to do the same thing. We're going to make a table with our x, with our function rule, x cubed plus 1, and our y as well as our ordered pair. Okay, so let's pick some values for x, and I think it'd be kind of fun here to pick some negative ones as well. So let's pick -2, -1, 0, 1, and 2, and I think that'll be sufficient. So we have -2 cubed would be -8 plus 1 is -7. So we have the ordered pair -2, -7. Taking -1 and cubing it, we have -1 cubed is -1 plus 1 is 0. So we have the ordered pair -1, 0. Taking 0 and cubing it, plus 1 would be 0 plus 1 is 1. So the ordered pair 0, 1. Cubing 1, we get 1, plus 1 is 2. And so we have the ordered pair 1, 2. And finally, taking 2 and cubing it, we get 8, plus 1 is 9. So we have the ordered pair 2, 9. All right, putting that on our graph, move this up out of the way. Let's see, I'm going to need positives and negatives, so I'm just going to draw my y-axis here in the middle and my x-axis in the middle, kind of. And here we go. -2, -7. 1, 2, 3, 4, 5, 6, 7. Just barely on the graph. -1, 0. 0, 1. 1, 2. And 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 will be right there. Okay, so didn't mean to write that there. All right, so let's join our points from left to right. And you can see it is not linear. In fact, this is a cubic function. And there is our graph. Okay, your assignment now is to do page 257 through 259, the odds 9 through 29, also 33, 37, and 39. There is going to be a quiz tomorrow over lessons 1 through 4 of chapter 4. We'll answer any questions that you have about this lesson first. Thank you very much and have a great day.